In the previous tutorial videos, we talk about solving the two kinds of problems, either all the elements satisfying a particular property versus at least one element in the array satisfying the property, right? So now, for example, let's say the property being all positive number. So now in version number 1, in all positive over there, we simply use the initial value to be true, and also we use conjunction for accumulation. And version number 2, we simply take out the accumulation, and we illustrated in the previous video that this is wrong because it only depends on the last element of the array being the comparison result. Okay, symmetrically, we also talk about version number 1 for sum positive, in which case the Boolean variable is initialized to be false, and also we use the disjunction to accumulate the result. And version number 2 for the sum positive, we simply took out the accumulation part, and then we illustrated why this is wrong. And again, because the result only depends on the last element in the array. Okay, so that's what we have achieved from the previous tutorial videos. If you have any doubts, please review them before you see the current version. So the current video over here, we want to improve our program. In the case where, let's say the array is very large, let's say the array we are trying to iterate through contains 1 million elements, but somehow, in order to give a result, whether for all positive or for some positive, what if we know the result already in the very early iteration of the loop? Is it possible to exit from the loop earlier? Okay, that's something I want to talk about. So but there's nothing wrong with version 1. You can definitely go for version 1, but you should really also know what's wrong with version 2. But now for version number 3 and version number 4, I'm going to show you some clever way to actually try to be more efficient for your loop. Okay, that's something I'm trying to show you. Let me just give you some intuition over here. Conceptually, this is the motivation for having some early exit. So you will see exactly what I meant by early exit. Early exit simply means you can exit from the loop as soon as it is okay to actually exit from the loop without compromising the result that you want to print out to the user. Okay, so now in the case of all positive, okay, we said before, as long as you can find a violation witness, a witness that actually violates the property, let's say in this case being positive, right? As long as you can find it out, you actually don't have to worry about the rest of the array anymore, because this particular one, -2 larger than 0 is just going to be false. If you try to make the conjunction with all the other elements in the array, it doesn't really matter because it's already false. So it doesn't matter what the rest of the array actually looks like. Okay, this will be very useful insight, especially let's say we got 1 million elements in the array. So the last index will just be 1 million minus 1. You got quite a bit to iterate through. If, let's say in the very early stage, let's say for example, let's say I got 3, I got 4, I got 1 over here. So 0, 1, 2, 3, sorry. So this should be index 3. Let's say as early as index 3, I found that the element is already -2, which means it already violates the property I'm trying to check. So now, do I really have to bother going through the rest of the almost 1 million elements in the array? The answer is I don't have to, because as soon as I see the very first violation witness, I can directly tell you that it's false, because it is not the case that all the numbers are negative. Oh, sorry, it's not the case that all the numbers are positive. Why? Look at -2. It proves that not all the numbers are positive, right? Symmetrically, let's say this. Symmetrically, let's think about sum positive. Okay, sum positive over here. Let's say talk about sum positive. In the case of sum positive, you can see, let's say we simply got -3, -4, and then 1. And let's say in index 3. As early as index 3, we find that this is a so-called satisfaction witness, which means this is the first witness we find early in the array that actually satisfies the property being positive. Okay, so now in this case, does it really matter how the rest of the array, almost 1 million elements, how do they look like? Does it really matter? The answer is doesn't, because 23 larger than 0 is just going to give me true. And then since we're going to use disjunction to accumulate the result, as soon as you get true as one of the operands, it will just be true for disjunction anyway. So it doesn't really matter. So now as soon as we see the very first positive number being the satisfaction witness, we can already declare the result being just true. Because there's at least one element in the array that's positive, because 23. Okay, that's the first one. So now this is kind of the motivation for us. We want to say, but you want to be very careful. When you want to check for all positive, you want to look for the violation witness. When you try to do for some positive, you want to look for the satisfaction witness. So now this is very much insight into having the version number 3 and 4. Okay, so what I will do is I'm going to show you version number 3 and version number 4 very quickly. Okay, and the way we trace it will be very similar, but I'll trace it for you anyway. Okay, so now let's do version number 3. Okay, so what I will do is I will go to version number 1 over here, and can I simply just copy? Can I copy version number 1 over here, and then I will paste. And then I'll simply paste over here. So now let's call it version number 3. Okay, actually I did the wrong thing. So now I want you to right click on all positive version number 1 and say copy over here, and right click, and then you can say paste. Okay, so that's gonna give you all positive version v3 over here, and say okay. Okay, if you double click on that, so this is the working version from version 1. So what we want to do is, so now let's say we still keep the accumulation over here. Let's keep it, okay? But now I'm actually going to show you what you can do to say, as soon as I find out the all positive becomes false, I'm going to exit from the loop. How do I control the entrance and exit of the loop? As we said before, in the loop, you have to, it depends on the state condition. So now what I want to say is like this. I would say, I will stay in the loop as long as I is a valid index of the array, and also all positive remains true. As soon as all positive becomes false, that means all positive is simply just going to cause the conjunction to be false, and then I'll exit from the loop. Okay, we're going to trace the code together. Okay, and then okay, everything else remains the same. So that's version number 3. We'll do version number 3 for some positive in just a moment. Okay, we'll do that. So now what I will do is I will copy the fragment of code over here, and then we'll do some tracing together. Okay, so now let's go to version number 3 for all positive. So what I will do is, as usual, I'm going to paste the code. Okay, let's put it here. Okay, let's try to do that. Okay, you can see the only change that you have to pay attention to is really this part here. Conjunction over here, and also the truthfulness for the all positive. Okay, so now let's try to see conceptually how many iterations do we need before we can exit from the loop. We cannot exit from the loop just yet because it's still positive, right? Because later elements might be negative. And also after this iteration here, we cannot decide just yet. But now as soon as we reach the third iteration at c-1, that means we find the violation witness. So now that means as soon as we see -1, that means it is not the case that all the numbers are positive. So now this is a point that we can exit from the loop and say false. Let's see exactly how this will work. So now let's try to trace the code. So now again, line number 1, we simply create this array called ns. And then we have our Boolean variable here. Initially, it's simply just true for the reason that we explained before in the previous tutorial video. Okay, let's try this. So now the state condition is a little bit more complicated. So what I will do is, so that's why I put I less than, so you can see I less than ns.length and also all positive. Okay, this is what we want to do. Okay, so now let's see exactly how this can be evaluated. Okay, so now in the very first iteration, I is simply 0. Okay, so what do we have to evaluate? How do we evaluate this particular state condition for the first time? I is 0 less than ns.length is 1, 2, 3, 4, 5, less than 5, and what's the value for all positive currently? Well, it is simply just true. Okay, 0 less than 5 is simply true. True and true is going to give us true. So this is the value for the state condition for the very first time. That means we're going to go inside into this particular body of the loop over here, and then we're going to execute this line here, right? Let's try that. So we're going to say all positive is reassigned to all positive and ns at position I, which is 0, larger than 0. In this case, we're talking about this particular element here, 2 larger than 0 is going to give you true. So this is true together with all positive, which is also true. True and true is going to reassign true into all positive, right? So that's going to be true. Okay, we are going to reassign this to be true. Okay, so far so good. Okay, let's do the second iteration. Let me use orange here. So now for the second iteration, I will be incremented from 0 to 1, right? Before the second iteration. So 0 to 1. Okay, now what state condition do we evaluate for the second time over here? So now for this one here, so 1 less than 5, and what's the current value for all positive? Well, it's simply just true over here, and true. 1 less than 5 is going to be true. True and true is going to give me true. So that means I have to execute the body of the loop for the second time, right? So now that means I need to execute the following. All positive over here is reassigned to all positive, the current value for that, which is from the previous iteration, is simply just going to be true. Okay, also you can see true over here. And also, and ns at position I is 1, larger than 0. Okay, ns at position 1 is simply just 3. So 3 larger than 0 is going to give you true. And true is going to give you true. That means we're going to reassign this expression over here, which is true, to all positive. So it's going to be reassigned to true. Okay, so far so good, right? So now let's see the third iteration, which is critical. So now for the third iteration, let me use green over here. For the third iteration, what we have is, because I would be, oh, by the way, from the previous iteration, you can see NSI, which is 1. And so that would be 3 larger than 0, which is true, just for the completeness of tracing. So now when we go to the third iteration, I will be incremented from 1 to 2. Okay, so now I'm going to evaluate this state condition over here for the third time. So that means 2 less than 5, we know that it is true. And also, what's the current value for all positive? Well, it's simply just true over here, right? So that'll be true. So now true and true is going to give us true. Okay, so that means we're going to execute the body of the loop for the third time. So now in this case, what we have is we can simply just try to do the following. Okay, let me just write it out. So all positive over here is reassigned to all positive, and okay, and you can know that the current value for all positive comes from the previous reassignment, right? You can also see it's true over here. So let me just say that it is exactly over here. So that's true. Okay, and then it's going to be ns at position. The value for I is 2. 2 larger than 0. What is that? ns2 is simply just minus 1. So that's the very first violation witness we encounter. So minus 1 larger than 0 is going to be false. False and true is going to give us false. Agree? And then for that one, so that means we're going to reassign false for this expression here to all positive. So that means all positive is going to be false. So now we're going to reassign that to false. So now let's see what's going to happen. Okay, now it's very critical. So now for the fourth iteration, okay, whether we're not going into the fourth iteration depends on whether the state condition will be evaluated to true for the fourth time. But now when I, at the end of the third iteration over here, oh, by the way, so for the third iteration, we simply got minus 1 larger than 0. That should be false, right? Okay, just make sure. And now for the third iteration over here, at the end of it, we're going to execute I++. So I would become 3. So now we got 3 minus 5 And we know pretty well that's simply just true. Okay? And also, what's the current value for all positive, right? The current value for all positive, as we have seen, is being reassigned to false. And now you can see the behavior for the program so far is exactly identical to version number 1. The only difference is now the state condition over here also depends on all positive, the value of that. So now it's become false. So now true and false is going to give us false. So that means we are going to bypass the body of the loop. That means from now on, we're going to bypass the body of the loop, starting from the... So that means we only execute the body of the loop for 3 times only. Okay, and now we are done. And then we're going to exit from the loop, and then we're going to print exactly the value for all positive. So what would that be? Well, it's simply the last... that's simply the result we simply got from the very first witness for violation. Okay, it would just be false, which is correct. Okay, so now what does that mean? That means these 2 elements over here are not actually looked at compared with version 1. In the case of the version 1, because the state condition here does not include this part over here, that means we always have to scan through the entire array from index 0 until index 4, until the last index. But now in version number 3, as soon as we find out the very first violation witness, we stop there. And then we just return true. Just print out false right away. And the rest of the array will just be ignored. Of course, in the worst case, let's say you got this particular scenario over here. Let's say you're simply, well, it just happened to be the case that, let's say all the numbers are simply just positive all the way throughout until the last number being negative. What happened in that case? Well, in that case, you have no choice, but you have to scan through the entire array, and then in the last index, you find out the result should be false, right? This they just some aside to actually mention to you. Okay, that's about the version number 3. Okay, so now let me show you very quickly how version number 3 will work, will look like for the sum positive problem. Okay, but for the tracing, I'm gonna leave it up to you. Actually, for the tracing, maybe I can do some debugger to show you. Okay, that'll be nice to show you. So different way of tracing. So now what about version number 3? So what I want you to do is right click on sum positive version 1. And then you will simply say copy, and then right click, and then you say paste. Okay, it's going to be sum positive version number 3. Okay, so what I will do is, if you look at version number 3 here, so now what I will do is, I will simply just strengthen the... Okay, let me just close everything here so I don't get confused. If I double click on sum positive version 3, and now I'm just going to strengthen the state condition over here. I would say %. So now what should I put over here? Okay, so now this one is a little bit tricky. Okay, what if I simply say sum positive? Think about what this means conceptually. I'm going to stay in the loop as long as I is valid, and also sum positive is simply just true, right? That's what I'm trying to say. But this one doesn't sound right because the initial value for sum positive is false already, which means the very first time you're trying to evaluate this state condition over here, false over here is simply just going to make this whole thing false immediately. That means don't even get a chance to really execute the body of the loop. So that's not right. So now what I would suggest is to write something like this. Okay, what does that mean? Well, by the way, this one here, this operator here is an exclamation mark, is the negation for logical, right? The logical negation operator. I think about it informally, okay? I'm saying that I'm gonna stay in the loop to repeat the body of the loop as long as I is a valid index, and also it is not the case I have found a positive number. If as soon as I have found some positive number when it becomes true, I'm going to exit from the loop. Okay, let's see exactly how this will work. Okay, so now actually I think that this one here might be a little bit easier for you if I try to trace on the iPad. We'll do the debugger maybe a little bit later. Okay, so now that's the program over here. So that will work. Let's just double check. Okay, So now if I simply do over here, so run as Java application, you will simply say true, simply because this is the very first witness of satisfaction for us. So basically, let's see how many iterations do we need in this case. We predict only 3 iterations will be necessary because the first and second numbers there are simply negative, so they are not very useful. But as soon as I see the very first positive number that can be the witness for satisfaction, I can say now, in that case, I will really set the sum positive to be false. Sorry, let me say it again. As soon as I see the very first positive number here, I'm going to have the property over here being true, and then it's going to set the sum positive to be true. And true, by applying not to true, is going to be false. It's going to cause the state condition over here to be false, and they're going to exit from the loop. Okay, that's a very informal way of saying it. Let's see exactly how this will work at the runtime on iPad. Okay, so what I will do is I'm going to copy this fragment of code, and then let's trace it quickly. Okay, let's now go to the version number 3 for is there a positive number? Okay, let me paste that over here. Okay, over here, okay, that's the loop over here. And you can see the only change was we have conjunction over here, and also we say it is not the case that some numbers is positive has been found. Okay, so now over here, what we'll do is, of course, you want to trace it, we can say, and it is not the case we have found some positive number. Okay, that's what I would do. So let's try to trace it quickly. And we predict it will only take 3 iterations for us to reach a conclusion without going further for the rest of the array. Okay, let's see exactly how this is going to work. Iteration number 1. Okay, so what I would do is initially sum positive would just be false, right? Initially. And then iteration number 1, I would just be 0. And how do we compute this particular state condition for the first time? So it's going to be the first time I'm trying to evaluate this state condition over here. I is 0 less than the length of the array is 5. And it is not the case. What's the value for sum positive? It's simply just false to begin with, right? Not false. Not false is just going to be true. 0 less than 5 is also true. So true and true is all just going to give me true. That means I need to go into the first iteration to execute the body of the loop, right? So that means I'm going to execute this for the very first time. So what I have is over here. So I got sum positive is reassigned to sum positive. The current value is simply just false. Or ns at position I, which is 0, larger than 0. And we'll talk about this particular element here. So we got -2 larger than 0, which is false. Okay, so now we got false or false, which is going to be false, right? So we're going to reassign false into sum positive, which means it's just going to be false. Okay, reassign that to false. Okay, that's the first iteration. Okay, at the end of the first iteration, we're going to increment the value for I from 0 to 1. Okay, from 0 to 1. So now we're going to evaluate this state condition over here for the second time. Okay, so we got 1 less than 5, and not the case, right? What's sum positive? Well, the current value is false. Not false. Not false is also still going to give us true, and 1 less than 5 is also true. So true and true is going to give us true. That means we got to go into the loop body for the second time, right? So now we're going to execute this fragment of code for the second time. So what would that be? So you got sum positive is reassigned to its current value, which was from the previous iteration over here, right? So that's just going to be false. Or ns at position I, which is 1. Right? ns at position 1 over here. Larger than 0, ns at position 1 is simply -7, minus 7 larger than 0 is going to be false. So false or false is going to give you false. So that means we're going to reassign false for this expression here to some positive. So that means we're going to reassign that to false. Okay, so this will become false. Okay, so far so good. So now let's see how the third iteration, which we think should be the last iteration, will work. Okay, so now let me just use blue over here. Okay, of course, don't forget, for the second iteration, when you get ns1 larger than 0, it's just going to be minus 7 over here, larger than 0, which would be false, okay, just for completeness. So now what about third iteration? At the end of the second iteration, we're going to increment the value for I from 1 to 2. Okay, so now we're going to evaluate this particular state condition over here for the third time. So now let's see what's going to happen. So 1 less than 5, okay, that's a value, oh sorry, not 1 less than 5. It should be 2, the I value, less than 5, and another case, what's the current value for some positive? It's simply false. Now false, again, is going to give us true, and then this is also going to give us true. True and true is going to give us true over here. Okay, and then let's see, we're going to execute the body of the loop for the third time. So what do we do? Okay, I'm running out of space, so I'll put it here. Let me just put it, okay, let me just move some space over here. Okay, just otherwise you can keep it a little bit messy. Okay, I'll put it at the bottom here. So now for the third iteration, we're going to execute this line of code for the third time. So what we have is some positive is reassigned to its latest value over here. Where does that come from? It comes from the last iteration, which is false, right? You can also see false over here. So it's going to be used over here. Okay, so it's going to be false. Okay, or ns at position I, which is 2, larger than 0. ns at position I is simply 4. So this is the very first satisfaction witness we encounter for being positive. So now this ns at position 2, which is 4 larger than 0, is going to give us true. So now true or false is going to give us true, right? So that means we're going to reassign true into some positive. So this some positive would be reassigned to true. Okay, so now, up to now, this behavior is identical to version number 1 for some positive. You can review version number 1 on your own. Okay, so now, what's going to happen here? Oh, by the way, so of course, for index 2, so that'd be 4 larger than 0, which is true, right? That's what we have. Now, it's very important to see how the loop is going to exit, which I will make a little bit more space for myself. Okay, like this. So now, at the end of the third iteration, I'm simply just going to increment the value for I from 2 to 3. Okay, 2 to 3. And now we're gonna evaluate the state condition over here for the fourth time. Okay, so the value for I is 3 less than 5, which is true, which means the index value being 3 is still valid. That's okay. However, what about the other half of the conjunction? So now and not the case for some positive. Some positive has just been set to true because in the previous iteration 4 larger than 0 is simply true, right? So now we got not the case, true. Not true is going to give you false. Okay, so now true and false is going to give you false. So what does that mean? That means as soon as the state condition is evaluated to false according to the meaning for loop or while loop, as soon as the state condition becomes false, you're going to exit from the loop. That means you're going to bypass this and exit from the loop, and then simply go outside the loop. And now the final result for some positive is simply just true. So that means when we try to print line, some positive, this is simply just going to be true. Okay, so now you can see this. But now I can appreciate that maybe you find this a little bit more difficult than the case for version number 3 for all positive is mainly this negation over here. Okay, you can see we want to say, okay, let me try to help you a little bit informally. Okay, and then before we move on to version 4, which will only take a few minutes to finish. Okay, for version number, for this particular explanation mark over here, thinking this way. So now we're basically saying that stay in the loop if, number 1, I is a valid index. So this is guaranteed by the left-hand side of the conjunction. I is strictly less than n is the length. Okay. What about right-hand side? How do you interpret that? Explanation mark simply means it is not the case. Okay. Number 2 is not the case. Okay. So now what about sum positive? The way you think about the sum positive, as we tried to explain in the previous video, is sum positive simply initialized to be false, which means we have not seen any positive number just yet. Okay, it's not the case that we have seen or we have encountered. How about that? I think that'll be a little bit easier. We have encountered. Okay, let me just try to spell that properly. We have encountered a positive number. Okay, we'll stay in the loop as long as 1 is true and the second is true, right? And remember what we said before. Okay, very quickly. Okay, if you say the state condition is simply P and Q, right? You can think about this is P, this is Q. So when so this is the state condition. What about the exit condition? It's simply going to be not the case P and Q, right? Which is equivalent to not P or not Q. Okay, so this is the exit condition. So we'll exit from the loop either because 1 is false, which means I is not a valid index anymore. We simply go to exactly I being equal to ns.length, right? That's how we learned before. But now, or it could be that as soon as it is not the case that Q is true, as soon as it is not the case that we have not seen a positive number, which means we have seen a positive number. You can see there's a little bit double negation over here, okay? I'm just trying to explain to you intuitively what this loop really means, because this negation over here is really crucial. If you forgot to include it, your loop is not going to work. It will just simply, as I said before, given that false is simply just the initial value for some positive, if you simply get rid of this, your loop will just terminate right away. Okay, so that's something you want to make sure you get it right. Okay, so please review this logic over here very carefully, especially for the version number 3 for some positive. Okay, so that will be the working version for version number 3 for both problems. So now I want to present to you version number 4 very quickly, and then I'll do a debugger trace for one of them, and the other one they'll be left to you as an exercise. Okay, so now basically version number 3, let me just give you a little bit of comments over here. Okay. Okay, so version number 3, basically, okay, so now we got early exit when possible, right? That's because the extra state condition we have over here, if possible. Okay, we got something similar over here. If you go to version 3, for all positive, version number 3, that's also early exit when possible. Okay, and over here, in the body of the loop, since we are also using the n% over here, that means we also accumulating the result. Accumulation of result from between iterations. Okay, let me just copy this line here, and if you go to version 3 for some positive, we're also trying to accumulate. It's just the way we accumulate is different between the two problems, right? One is using conjunction, the other one is using disjunction. Okay, so now let's see how exactly version 3 works. So far we have seen 3 versions. Version 1 works. Version 2 doesn't work. Version 3 works. Let's see the most concise version you can have, okay? Which is very similar to version 3. So now let's do this quickly. So now can we right click on all positive version 3? And then you simply say copy over here. And then right click and say paste. And then over here, we're going to say version 4 for all positive. You will say OK over here. Okay. And now if you double click on all positive version 4, the only thing I want you to do, let's keep this particular early exit, that which we want to keep, because we want to make sure for a very long array as an input, you want to make sure you exit as soon as you see the witness, right? So now the only thing I want to get rid of is the accumulation. Remember when we talk about moving from version 1 to version 2, we got rid of the accumulation, and that caused the program not to work. Now, when we go from version 3 to version 4, okay, version 3 to version 4, we also got rid of the accumulation. Is the program still going to work? The answer is it's still going to work, but let's see why. Okay, so now what I will get rid of is exactly over here. Okay, no accumulation. So that means as soon as all positive becomes false, the state conditions, which is over here, becomes false, and exit from the loop. Okay, that's the comments I would like to give to you. And now, can we just do something similar for version number 3 for the second problem? Okay, so now can you right click on some positive version number 3 and then say copy here, and then right click and say paste. Okay, so now version number 4, that's good. So now let me just change that, and I will give you the comment as well. The only thing I want to change is get rid of this accumulation over here. Okay, and then let me just go back to version number 4 for the other problem there. I just want to copy the comments. We'll fix that a little bit. Oh, by the way, it should be exit. Okay, so now I'm going to copy these 2 lines over here, and then I'll go to version 4 for some positive. And can we just replace this line here with these 2 lines? Okay. Okay, no accumulation of the result between iterations. That's true. As soon as some positive becomes true. As soon as it becomes true, so this becomes true. Not true is going to be false, which is going to make the conjunction false, right? The state condition becomes false and exit from the loop. Okay, so that's the version number 4 I want to give to you. Okay, version number 4. Okay, one more observation for you. Okay, as I mentioned before, previously, when we move from version number 1 to version number 2, or from version number 1 to version number 2, we got rid of the accumulation. However, the way we scan through the array is by the entire array. We go from index 0 until the last index. So that means version number 2 simply didn't work because the result depends on what the last element is. Okay, that's why version number 2 was wrong. But now, when we move from version number 3 to version number 4, and from version number 3 to version number 4, now, because the state condition is actually somehow stronger, in the sense that it's more complicated, so it's going to make sure as soon as your reassignments is going to make the Boolean variable either true or false, depends on which problem we are trying to solve. It's going to make the state condition false. It's going to make the state condition false accordingly, so we can exit from the loop. So we don't have the problem that we actually used to have from version 1 to version 2. Okay, that's a very important insight for you to really see what's the relationship between version 1 up to version 4, right? They're somehow interconnected. So you want to really understand why changing this particular state condition is going to make things still work, but why getting rid of this accumulation part is going to make something that doesn't work. Okay. So now, finally, what I want to do is, really for completeness, I want to trace one version there by using iPad, and one version there using debugger to really show you the entire story. Okay, what about for all positive? I'm going to show you the debugger. Okay, so all positive version number 4. Okay, for this one I'm going to show you the debugger, but for the some positive version number 4, I'm still going to show you the iPad. Okay, Okay, let's see exactly what we can do. So now, let's see this. You know what? Let me change my mind right away. I think it would be more interesting to trace this thing over here using the iPad, but now for version number 4, I'll show you how you can trace this particular interesting expression over here using the debugger. Okay, that's what I want to do. Let's move on to iPad first. But before I do that, I want to copy and paste the code. Okay, I'll simply copy this fragment of code. Okay, just to be complete. Okay, so now let me go to all positive, version number 4, which is going to work. Version number 4 is going to work very similar to the way version number 3 works, except that there's no accumulation. Okay, let me just make it a little bit bigger. Okay, let's try this. Okay, so now again, let's notice the thing you want to look at. So again, this is a complicated state condition over here. So not only that I is strictly less than ns the length, and also all positive. Okay, that's what we have, right? And then we're just going to see exactly how it will work. So now let's say we have this particular array. So now for the very first iteration, I is just going to be 0. So 0 less than the length of the array is simply 5. And, oh, by the way, the initial value, oh, I forgot to copy. So, of course, the initial value for all positive should be true. Okay, I just forgot. Okay, let me write it down. So Boolean all positive is initially true. Okay, it's simply just going to be true. So I'm going to put true over here. And then, so now initially the value is simply true. So true, and this is true, true and true is going to give me true. I'm going to evaluate this for the first time, right? So that means I got all positive is reassigned to ns at position 0 larger than 0. ns at position 0 is simply 2. 2 larger than 0 is going to give you true. So we are reassigning this true to all positive, right? So that's going to be reassigned to true. Okay, now at the end of this first iteration, we're gonna okay, let me just also do this. Okay, so that means we got 2 larger than 0, which is going to be true. Okay, and now at the end of the first iteration, we're going to increment I by 1. So now that means it will be incremented from 0 to 1. So 1 less than 5. So we are evaluating this state condition here for the second time. 1 less than 5, we know that it's going to be true. And so what about all positive? It's currently simply just true, right? So it will simply be true. True and true is going to give you true. Okay? And then, of course, so we are talking about this particular, the state condition is simply true. That means we're going to execute the body of the loop for the second time, right? For the second time, what do? All positive is simply reassigned to ns at position I. In this case, simply 1. At position 1 is larger than 0. ns at position 1 is simply 3. 3 larger than 0 is going to give you true. That means we reassign this particular expression value true to all positive. So reassign that to true. Okay, so far so good for the first 2 iterations. Okay, and don't forget, it's simply 3 larger than 0 is true. Now for the third iteration, we're going to have I incremented from 1 to 2. So 2 less than 5, and the current value for all positive is still true, right? Okay, this is true, and true is going to give you true. That means we have to evaluate this body of the loop for the third time. So we have all positive at position 2 larger than 0. So at position 2 we got -1. -1 larger than 0 is going to give you, oh, actually I should say all positive is reassigned to, right? So now -1 larger than 0 is going to give us false. So that means we're going to reassign false into all positive. So that will become false. So now it is false. So now what's going to happen? The behavior is exactly the same as what we would expect in the version number 3. So now in this case, because we know that because now the state condition, of course, -1 larger than 0 will become false. Okay, the state condition here, what would that be for the fourth time? So now we're going to evaluate the state condition over here for the fourth time. So the value for I, let me just move a little bit space for us. Okay, now for the fourth iteration, possibly, so what we'll say, I was incremented from 2 to 3, so 3 less than 5, this is still true. So it's still a valid index, and the value for all positive, and now this has been changed or reassigned to false from the previous iteration already, right? Because -1 larger than 0 is just false. Okay, so now we just get false. False and true is going to give us false. So that means it's simply false. That simply means we're going to bypass the body of the loop, and we don't really execute it for the fourth time. So that means we're done. So that means the rest of the array is simply bypassed. We don't look at that. We exit from the loop. So once we exit from the loop, when we say print line over here, and then we simply got all positive to be printed out, and what should be its value? Well, the last value for the reassignments was simply false. So that's the correct result. Okay. So this version number 4 still works, but version number 4, you can see the evolution over here, right? We got a more sophisticated state condition over here with a conjunction. On the other hand, for the body of the for loop, we don't have to use accumulation. Okay, so now you really want to compare the 4 versions, between one and another. Okay, so now this one also works. Okay, so now what we want to do for the last thing, for completeness, I want to show you how version number 4 for the sum positive problem actually also works by using debugger very quickly. Okay, so now what I will do is, let's look at, let me just close everything here so we don't get confused. Okay, I can also clear the console over here. Okay, so now for sum positive, so the example I'm using is -2, -7, 4, 5, and -1. And now, when do we expect to exit from the loop with this early exit version? You can see that we still got this particular sophisticated state condition here. So now we want to make sure it is not the case that we have seen some positive number. As soon as we have seen some positive number, we should exit from the loop. Okay, that's kind of logic over here. So let's try this. So let me simply put a breakpoint in the beginning of the for loop over here, and then we'll see how things work. Of course, when we pause the execution at line number 9, we're going to see some positive is simply initialized to be false, right? So now what I will do is, you can also use this opportunity to actually see if you can trace your code using debugger. So now I would say right-click on sum positive version number 4, debug as Java application. Okay, so now we are switched to the debugger perspective. Okay, so now if you look at the variables over here, you can see for sum positive is being initialized to be false, right? And also for ns, that's the array, is at exactly -2, -7, 4, 5, and -1, right? You can look at that. You can see that's exactly the layout for the array, which we covered in the previous tutorial video. Okay, so now I want to make use of the expressions over here. Okay, let me just get rid of all of them, the previous one. Right-click and say remove all. So now I want you to pay attention to the following. First of all, we want to see what the value is for I. At the moment, it's right before we try to execute the head of the loop, so I is not initialized just yet, but that's okay. I'll just write it down. We want to know what's the value for I, and what's the value for I, also ns dot length. Okay, I want to make everything clear to you. Okay, and then what about the left-hand side for the conjunction for the state condition? I less than ns dot length. Okay, currently I doesn't exist just yet. Okay, and then also we have what's the value for sum positive? At the moment, it's simply just false, right? What about the negation of that? Not the case, sum positive. Okay, that should be true. You can see from false to true using negation. And then I want to copy the state condition over here. I can simply just highlight it, and then I can simply right-click and say copy. Okay, I want to see what's the result. I can see add expression, right-click and paste. So that's the state condition. At the moment, I doesn't exist just yet, so that's why it got error. That's okay. That's expected. Okay, and then I think that'll be it. Okay, so these are the expressions we would like to monitor throughout the execution. Okay, let's see exactly. So how many iterations do we expect to see? It should be just 3. As soon as we evaluate the state condition for the 4th time, we don't have a chance because you will evaluate to false. Okay? Let's see. So now I will be initialized to be 0. So that means this will be 0, and then 0 less than 5 is going to give you true. And also, what about this part here? Okay, let's just try to execute it. Okay, so now if I simply just say step over here, as soon as I say step over, okay, let's see exactly. I was initialized to be 0, okay, and then 0 less than ns.length would just be true. That's the left-hand side of the conjunction. The initial value for some positive, as we have seen, is simply false. Not some positive would just be true. So we are saying true and true. That's how we get this particular result, okay, for the state condition, which is true. So that means we're going to go into the body of the loop for the very first time. So now what do we expect to see? Some positive will just be reassigned to ns at position I. Okay, so now let's try that. Ns at position I is simply -2, right? If you look at the variables over here, ns at position 0 is simply -2. Okay, so now let's go back to expressions over here, and then you can see ns at position I is larger than 0. That'll be false, right? So that means we're going to reassign false over here to some positive. So I want you to look at the value over here, which is not going to change, right? False is reassigned to false again. Okay, so now if you say step over, okay, you can see some positive remains to be false. That's okay. So now what we expect to see is I will be incremented by 1 because of the I++, right? Once I is incremented by 1, what do we expect to see? If this is 1, what would be this expression? 1 less than ns.length, which is 1 less than 5, will give you true. And also, what about some positive? Some positive remains to be false from the previous iteration. So now, not some positive will just be true. Okay, the same as before. Let's try. If I say step over here, let's see this. Okay, at the moment you can see I has been incremented to 1 from 0 to 1, and then we got the state condition here. I less than 5, 1 less than 5 will just be true. And also, if you try to evaluate this particular not some positive, it will be true. So true and true will just give you true. Okay. It seems to be a little bit more sophisticated using a debugger. I want to show it to you because I think it's really important for you to practice this. Okay. Right. And then NSI will just be number -7. So now -7 larger than 0 will give you false, which means I will reassign some positive to be false again, which it doesn't change. Okay. So now if I do that, okay, it will simply just be false. Okay, let's do one more. Okay, that's really critical. So now I is going to be incremented from 1 to 2. And what do we expect to see? Well, because some positive still remains to be, some positive still remain to be false, which means the negation of that will still be true. So that means this part still is true. And then I, once incremented, will be 2. 2 less than 5 will still be true. So that is still fine. Okay, if I try to say step over, you can see we're still going to loop for the 3rd time. Okay, you can see I is being incremented to 2, and also the state condition reevaluate to true as well. Okay, so you can see that corresponds to exactly how we trace using the iPad. But I want you to also be familiar with how to use the tool to trace it. Okay, so now here comes the critical points. Okay, so now the value for I is simply 4. If you go to, let's go to variables, index 4 for NS will be simply, let me do it again. If you look at the value for the value for I is simply 2. Okay, if you go to variables and then NS at position 2 is simply 4, which is positive. That's the very first witness for satisfaction we are encountering. So you go back to expressions over here. So what do we expect to see? So that means NSI, which is 4. 4 larger than 0 will give you true. So that means some positive we expect to see after this particular line number 13, after we say step over, it should reassign some positive from false to true, right? So now we say step over. You can see exactly this is true, right? Okay, you can see now the sum positive has become true because the previous one we simply got NSI being 4. Okay, so now it's really important to see why we are going to exit from the loop. Simply because you can see that sum positive is now true, which means the negation of that would be false. So that means this part over here is simply false. Okay, this part over here is simply just false, even though the left hand side over here, which will be I value, which is 2 less than ns.length, will still be true. Okay, so now let's try to step over it again. You will see that what we predict to happen is not sum positive will just be, oh, there's something I said wrong. Sorry about that. Because now when we try to evaluate this state condition again, I will be incremented from 2 to 3. Okay, so that means 3 less than 5 will just be true. Okay, and then but this part over here, not true over here, will just be false. So now you get basically true over here and false over here. So you get false. So now watch what's going to happen. What should we expect to see if I say step over? Are we going to still enter the for loop for the 4th time? The answer is no, we don't do that anymore. As soon as I say step over, I actually exit from the loop. So now I go directly to line number 16. So now if I try to print out some or at least one element in the array is positive, if I say step over, it's going to print out the value for that, which is true. If I say step over, you will see some elements in the array is positive, it will simply be true. Okay, so now I really want you to see the way I trace the program using debugger is equivalent to how I trace the program using iPad. You really want to get comfortable with both. Both are valuable tools for you as a programmer. Okay, so now let me just recap very quickly for you, okay, verbally. Okay, I can write something down for you as well. Okay, let me just stop the debugger by clicking on stop terminates, and also let's switch back to the Java perspective. Okay, so now what I want to do is summarize very quickly for you. Okay, for version number 4. Okay, so now what I want to do is over here, the comments. Version number 1, scan the entire array. Okay, let me just put it here. The state condition is I strictly less than ins.length and with accumulation. With accumulation, i.e., we simply say all positive is reassigned to all positive n%, ns at position I strictly larger than 0. That's version 1, and this one works. Okay, what about version number 2? Okay, let me just copy and paste quickly. Version number 2, we still keep the same state condition here, but without accumulation. All positive is simply reassigned to the last the current element we're looking at. So this one does not work. Okay, because it only depends on last element, as we tried to explain before previously, right? So now let's see version number 3. So version number 3 over here, version number 3. So now you don't actually scan the entire array. So now we will say may exit early. Okay, so now the state condition is this original one, we make it more complicated, and we say all positive. Okay, as soon as this all positive becomes false, we're going to exit from the loop, and with accumulation, right? So that one works. That's the version 3. Okay, so now what about version 4? Version 4 is the most concise version. We got early exit, also we don't have accumulation. Version number 4, so we got may exit early, so the state condition over here, and without accumulation. So all positive is simply reassigned to NSI larger than 0. You can see version number 4, version number 3, and also version number 1, all of them work. but you want to know exactly why they work. And also, equally importantly, you want to know why version number 2 doesn't work. Okay, that's like a recap for the first kind of problem, for checking that all the numbers or all the elements in the array satisfy a particular property. Okay, so now let's do a quick summary for the second kind of problem quickly. Okay, let me just copy this and let me go to sum positive version number 4. Okay, let me just paste over here. Okay, version number 1 will scan the entire array the same as before and with accumulation. So that will be sum positive is reassigned to sum positive, and now for this kind of problem we say disjunction for the accumulation, right? So that works. Version number 2, scan the entire array the same as before, but now without any accumulation. So sum positive will be just that. Does not work for the same reason. And now for version number 3, may exit early. So now be careful over here. So now I less than ns.length. So now, because the initial value for sum positive is simply just false, so you want to make sure you add an exclamation mark for logical negation for that. Okay, remember. Okay, of course you don't want to memorize this. You don't want to just memorize this. You want to really understand the logic over there. It's easier for you in case you forget. Okay, with accumulation. So now we'll say sum positive is reassigned to sum positive, and then disjunction over here that works. Finally, for version number 4, may exit early, okay, with the same state condition here, just not sum positive. Okay, like that. And then, and without accumulation, we simply say sum positive, okay, is assigned to NSI larger than 0. That works. So now for the second kind of problem, version 3, version 4, and version 1, all of them work. And version number 2, it doesn't work. Okay, so you can see overall up to now for this week's tutorial video, we have seen 1, 2, 3, 4, 5, 6, 7, 8. We have seen 8 blocks of code. You really want to see exactly, number 1, the 2 kinds of problem we are trying to solve. Either all the elements satisfy a property versus at least one element satisfy a property. And all the 4 versions we are trying to summarize over here. Make sure you understand all of them. Okay, that's my expectation from you, given that I try to explain to you so thoroughly. Okay, if you got any question, you can let me know. Otherwise, review the video if you got trouble.